Yes, ma'am.
Your number 4 is different.
My number 4 is different?
Yeah.
Well, what do you have?
0.25 seconds.
Oh yeah.
You switched them.
And point,
And the next one is
point one at the bottom.
Oh, right here?
Yeah.
Huh. I wonder if that's true. How's that? Okay, thank you for catching that. Okay, so look at the magic pen. In fact, let's change the color. We can do, what color do you want? Blue or red?
Red.
And you can write big or small. So now when you come up here and you do, you can, isn't that fun? Okay, you want to erase, you hit this. So I thought I'd let you have fun. Who wants to, 2 people start, you can fill in any one of these that you want.
Right now we've got
Uh-huh.
solved the.
Here you go, I saw your hand go up. Oh, sorry. So go do whichever one you want, and then when you're done, pass your pen, magic pen to the next person, and we'll just keep going like that until it's all done. Well, I'd do number 2 if you have.
You didn't do it?
And if you do it wrong, it's okay, we'll laugh at you and then correct it. I'm just kidding, we won't laugh. We'll just snicker, gently snicker. Let's see, if you hit this right here with your pen, it'll get rid of that. There you go, sorry. That's all right, you're doing fine, no apologies.
One comes in, I'm the only one of it.
One at a
Yeah,
time.
somebody else is coming. You're doing great. I think. I don't know. I haven't checked.
Yay.
If you want to pass the pen to somebody else, you can certainly pass the bush to, yeah, to whoever you want. Just bring it on. Yeah. What?
Who you did yours?
No.
Oh, dude. So, somebody else up. See, now the pressure's
You want to change the color? You can do that too. If you didn't get that done, you don't have to panic or anything, just maybe on a
I rounded
separate
up.
sheet of
Look how nice Evelyn's writing is.
Kitty takers.
Oh, yeah, hang on to that. Well, go ahead and give it to somebody, and then we can just, we're gonna go to that.
Duck,
You
duck,
don't have to
duck.
pass, just hand it over. And if you don't have it done, that's fine, you can work it up here. You should hopefully know how to do that.
No.
No.
They're doing it right now.
Which one? Just anybody you want. Okay, let's look.
Oh, number 5.
Okay, remember the reciprocity law? This is like one of our very first formulas where you have mass 1 is equal to mass 2. Any MA in time combination will equal to another MA in time combination. So look at this one, 600 MA is correct.
Mhm.
Those of you who did it, is that what you got?
Yeah.
Okay, number 2, in order to maintain a clearly defined radiograph and eliminate motion. So again, that is why, you would use a reciprocity law. We ask that in lab, under what certain conditions would you use a reciprocity law? And typically, 10 mass is 10 mass. I don't care what you use, but it does become critical when you have a patient that may not be able to hold still. You're doing a pediatric patient who can't, follow instructions. You're doing an ICU patient who's on a respirator, who can't control their breathing. So we typically like our short exposure times. Even for a patient who can cooperate, we have a chest x-ray with the heart beating, peristalsis in an abdomen. So there's lots of times when you want to decrease your time, and in doing so, that's fine, but you've got to compensate for that with your MA. So typically we use short exposure times and higher MA techniques. Which of the following would do with changing the technique to 100 MA at 0.5 seconds? And here, this is what I tend to do, what mass is that? And so we're trying to eliminate motion. So without having a multiple choice, at any situation, you want to eliminate motion, what are you gonna do?
Shortest time.
Shorten the time. So what we want is something less than that. But yet, keeping that same exposure. And so, employ the highest MA value in shortest time and still maintain your 50 mass. Is there a fastest MA? No. There's a high or lower MA, but not a fastest. Leave the MA at 100 and increase by 30 kV. Is that going to do anything for motion?
No.
Not a thing. 200 MA, you have 1/20th of a second. What mass is that?
I think it's like 10 mass.
10 mass. Is 1/20th of a second shorter than 0.5?
It's 0.05.
It's shorter, but it doesn't give you the same.
That's 50 versus 10, so.
Yeah. So it's not maintaining the technique. Okay, good. So number 3, here we have that 20%. It kind of drives you nuts, doesn't it? I got 0.27.
Yeah.
Okay, so the work's not up there, so I don't. No, it's okay. Don't.
I think you forgot to address the 20%, Renee. Yeah.
Okay, so.
I think that's what it was.
So what I tend to do on this is multiply. I don't know, this is just me. I always find the mass. It gives me a better idea of what's going on. So I tend to do the mass, but 300 MA times 0.3 seconds is 90 mass. And then you take 20% of that, which is 18, then add it back to the 90 mass. Now, what have you done? You increase the mass by 20%. So you've taken care of that part. Now you do the reciprocity law. So then you have 108 mass. Who has a pen? I will give it back. Then at this point you have 400 MA. We don't know what time is 108 mass. So then you just do your math. Divide by 400 here, 400 there, and I got 0.27. Close. In real life, that would work, just so you know. But for test purposes, make sure you do that 20%. So if you have trouble with those little percentage ones, it's a 2-step process. You have to do the percentage first and then figure out the reciprocity law. Okay. Oh, and then number 4, again, it's under reciprocity. On your test, I don't say, give a category and then all of that. So you have to know what to do with it. But anytime we're having an uncooperative patient or a motion issue, it tends to be your reciprocity law. And so 1,000, that's what I got. Did everybody who got that? Any questions about these up here? Look at that, isn't that cool? Let's get rid of them. Okay. Okay, whoever has the pens, come on up and do these. Are these the same as? Oh. Okay, hit this, okay. Don't like it. Do that. And then hit the smaller one. That's fine. Oh, no. And so, this. In this case, since she's already writing, we don't want to mess her up. Oh, don't write for just a second, please. And so we can do this. You have to kind of hit it. There we go. Don't know what it's typing. Okay, try, let's see. Okay, sometimes you have to hit that little arrow down here to the right. And then, a little bit, there you go. Now go back to your writing. Sometimes you just have to reactivate it. There, you got it. There you go. Still active. You got it. Sometimes you have to go a little bit slower too. There you go. Now go give that to somebody else. Please.
Another one?
Oh, I can't reach up there.
I'm gonna do it? Or I'll do it.
The tall one gets the low one.
Come on, Grant.
Oh, what? 5? Okay.
I got it.
I just teased you because you're so tall.
I know. Like, how am I supposed to write down here?
Didn't think about that. I can read it,
Is there any?
I'll just round it.
sometimes if it stops, you can go over here to the left.
Because it was like,
He might be blocked.
it was like 4 seconds.
Okay, so look at number 5. Each one of those should equal 20 mass, so what you can do is just take 100, let's see, 20 mass, 20 divided by 100, 20 divided by 200, 20 divided by 300, and you'll get those numbers, so those are correct. Number 6, we have 300 at 15. What is the exposure time? What did you get, everybody?
0.05.
Everybody get 0.05?
Mm-hmm.
Yes, the number is different.
Okay, and then number 7, 400, there's the answer there. And then number 8.15 seconds. Okay, these are the types of problems you're gonna have on your test. Nothing different than what you've had here. Nothing, I'm not gonna try to trick, make it harder, or anything like that. So if you got these and you were okay with these, then you don't need to study that. You're in good shape. Any questions about this? Anybody need an explanation on anything? Yes,
For the
ma'am.
test, are you gonna mark each one? Oh, it's
Reciprocity.
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 Or-
No, I'm not. So
Okay.
you'll need to recognize what it is. And that's what I'm saying about reciprocity. If you look at these questions, a lot of them will say, you know, what is the new MA value? So that might be a hint, or an uncooperative patient, or we want a reduced exposure time. Those are gonna be your reciprocity type questions. So you need to be able to recognize that. Okay, for instance, like on patient exposure, who has a pen? It's like I can't hardly do without this. So, for instance, patient dose is pretty easy to recognize because of the ESE. And again, these questions will be presented this way. I'm not gonna all of a sudden go rogue on you and do something different, you know. Okay, yeah, go ahead. Whoever has the pens, go right ahead. These two, I just had a couple on patient dose. I think that's a pretty easy mathematical thing, you know. What's the relationship? And I can ask you those, and I'm gonna ask you those kind of questions too. What is the relationship between patient exposure and MA? So as MA increases, patient exposure increases, leaving everything else the same. And so it helps when they show their work.
I think I switched to eraser.
Oh, okay, which is possible. And then hit the little red. Wait, stop writing
sorry.
this, Kathleen, just for a second. It's freaked out because of both.
Freak it out.
Double fields.
Yeah. I just got, there you go, now you're good.
I think I was hitting the button here. No.
Oh, yeah. Yeah, it's a little finicky, so you have to.
Alright. Okay, let's go.
And then we have, yeah, good for you. Okay, for the first one, that's what I got, and the second one, how are we doing on the patient exposure? You okay with that? It's a direct relationship. Okay, very good. Okay, 1/60 of the second to milliseconds. Is that right?
I got 16.6. That
Well,
should round it up.
16.6 or 16.7, if you round it up to 17, that would probably be okay. I mean, if this was a test, I would count that. Oh, yeah, 16.7. Okay, let me fix mine. Okay. Good. Perfect. Any questions about that? On your test, I don't think I have, oh, I better not say that. You need to make sure you can convert seconds to milliseconds. Not so much fractions so much because your equipment is not on fractions, but definitely between seconds and milliseconds. You may work at a facility, well, I don't know. Kim DeAnda, if some of you got to talk to our clinical application specialist, and I knew this, and she brought it up, all facilities radiology facilities will have to go DR in order to get reimbursed by Medicare, Medicaid, or whatever it is. So we have a couple of hospitals right now that are CR only, and they're going to be switching over. So hopefully, maybe by the time you get there, they'll be switched over to DR. Doesn't mean that you won't be working at a place that has older equipment and is not DR. Radiology departments do not have to go to DR, but only if they want to get reimbursed. So that's up to the facility. So you could be working at a place that has just CR. I don't know that you'll be working with equipment that'll be in fractions. That's pretty, that's what I started off with, fractions. So I'm more concerned about this part than I am that part. But if you can do that, then that's good too. Okay, density and contrast. Who has the pins? Come on in. Multiple choice. There you go. Sometimes you have to push this little button here.
Oh.
You're doing that, and then, I don't know why it's like no one's used me for a while. There we go. Okay, while they're doing this, we want the least amount of density, or I'd probably on your test put the least amount of exposure. And so, what are you looking at as far as MA, time, and KV go?
High end.
Least amount. So what kind of MA on number 12? The lowest. What kind of time?
The
The
fastest.
lowest. Are you recognizing that you have a variety of time, time, your fractions, milliseconds, and seconds? I mean, how mean can that be? I can't done that. And then what kind of KV? Lowest amount of KV. So that's the one you're looking for. Do you want to use your numbers on that? That's good. On number 11, we're looking for the greatest amount of exposure, so it's just the opposite. Thank you for encouraging. Call it encouraging.
Okay.
Not pushy.
We'll say that.
And teach you how to paraphrase. And then number 12, we're looking at the radiograph with the highest contrast. Highest contrast, so what kind of KV are you looking at?
Low KV.
Low KV. So that's green. Okay, basic. 4.
I got this one off.
I know, on 12 and 11, oh, 11, gosh, whoa. Oh my goodness.
The superior
I
12,
had-
inferior
I
12.
was green. Okay. Oh my goodness.
I didn't even notice that's all
That's the
right.
same way.
Yeah.
That's crazy.
The first 12 is all 100 MA. Massive.
The first 12?
The first
Oh,
12, the
No,
top 12,
I got C.
all 4 of them.
Oh, all 4 of
I
them
think for
are,
A,
okay, so if
Vicky,
you
the
go
1
through and
second
pick out
gets
the
through
mass,
because that's
it's
the
100
highest
mass.
amount
Yeah.
of time.
And then
It
you just
is,
look
huh?
at the highest KV.
Lowest.
I mean,
Lowest
lowest,
KV.
lowest.
Yeah, that's right.
lowest. Yeah. I did it right the first time. So, I mean, you could either do your numbers or go through and do the mass of each one. And you're right, that one does get the 4. Okay, I think. And this is the one.
Who wanna go next?
And I'm not gonna fix it. Thank you. Oh,
No, you have to
but
hand it
send
out.
this- give that to somebody else, please. That way, see, you're not all mad at me, you can be mad at each other. There's a method. Okay, so number 12, the least amount was C. And then number 11, the greatest amount was D, very good. And then again, on the second 12, you're just looking for the lowest KV regardless.
Oh, I didn't realize that, it was too close.
Wouldn't
Let me ask you-
high KV give high contrast?
Low.
No, high KV gives low contrast.
Low KV,
Oh, yeah.
high contrast.
I was going with.
Let me ask you about mass. How does mass affect contrast? Is mass a controlling factor of contrast?
No.
No, but let me tell you how it can affect contrast. If you have too high a mass or too low a mass, it can ruin the contrast. Does that make sense? If you've overexposed the image, it's gonna be dark and you can't appreciate any contrast that's on there. Or if you really underexpose the image, you may not be able to appreciate the contrast. So it doesn't control the contrast, but it can certainly obscure it. Okay, good.
Now move on to the real number 13.
So am I right after this? this one right here. And then and then, oh, there you go. Oh, that's gonna be the difference.
I don't remember velocity. I still require that one. I don't remember.
Okay, so we did that 15% rule. Usually, you use the 15% rule when you're gonna change contrast. That's the only reason I change KV personally, is if I wanna get a different contrast range. However, just so you know, the other thing about the 15% rule, you need to have enough KV to penetrate the body part. So if the KV is too low, increase it every 15% to get the right range that you want for penetration. We will learn when we talk about DR next week that our contrast range typically tends to be the same no matter what KV we use. So we'll need to worry about KV for penetration purposes and patient protection. Yes, with DR digital radiography, the computer will always put us in the right contrast range, typically, KV wise.
So, for example, if you wanna do 120, but
Okay, you use the one that you have.
if you wanted 120, but the system adjusted already to 100, go back to 100, but I mean, it doesn't do 120.
You won't see a difference between 100 and 120 on the computer image. No, but if you're doing a barium study on a large person, 100 may not work. You would need to go to 120 for penetration purposes, not because it makes your image look better. So we'll talk about that more next week when we talk about DR. In the film system, we use KV to control images in black and white and shades of gray. When you do that on your computer, KV doesn't, you don't have to worry about that now with digital. But what you have to think about is enough to penetrate the part. If you want patient exposure is less, if you use higher KV techniques. So it's a little bit different with DR versus, the contrast. It's all gonna be in the middle. Yeah, and I'll show you why next week. No matter what you use, it comes out good, right? Pretty much. Yeah, pretty much. I mean, you can.
Any
still
takers?
put them on and still be out of your exposure index.
Any takers?
I wanna see what happens. Remember, 14? Well, see, the key word here is a diagnostic image. So that tells me it was a good exposure, because they have osteoporosis. We didn't get the contrast that we wanted. Yes, just adjust the KV because that controls the contrast. Or the mouse on your computer controls the contrast. So, okay, let's look at these. On number 13, decreases, increases, and
What was velocity? I don't remember velocity.
Velocity stays the same. Speed of light, speed of light.
wait, let me have the pen.
Is that what it was?
Well, I don't have to have a pen. I can do this. I can do other things. Okay, look
Does
at
it increase?
Okay, when you need to be able to describe an X-ray photon in terms of frequency, wavelength, and energy. Okay, so if I draw a wavelength, an X-ray photon such as that versus separate this A and this B. Okay, so how would you describe this X-ray photon in terms of frequency?
High frequency.
High frequency. What about wavelength?
Short wavelength.
Short wavelength, or decreased wavelength, short wavelength. And then what about energy?
High energy.
High energy, and that one's the opposite. So what controls whether an X-ray photon looks like this or it looks like that? What controls that?
The KV.
KV controls whether it has a high energy or a low energy. What kind of KV is this?
High KV.
High KV, what kind of KV is that?
Low KV.
Low KV, absolutely. So, as the frequency of an X-ray photon increases, the wavelength decreases, the energy increases, velocity. Which one is faster, A or B?
Both the same, huh?
And how fast are they?
Speed of light.
Speed of light. They all travel at the speed of light, whether it's a very low energy X-ray photon or a high energy X-ray photon, the velocity is the same, speed of light. Light photons, radar waves, micro